Hi, so now I'm going to walk you through some just like really basic stuff about atomic orbitals and like what the point of all this is in the first place. So the idea here, the goal of this part of the unit is pretty much that we're trying to figure out um, where electrons are in the nucleus, or in the atom, I should say. They're not in the nucleus. Um, in general, this is what you've been taught for a long time. You've been told there's a nucleus in the middle with protons and neutrons. And around the outside of that nucleus, there are these energy levels that electrons sort of generally just orbit around. And you have these electrons there, and they orbit. And it's kind of like the solar systems and the planets. And, that's the thing is, like, that's not really that right. I got a new pen. Um, that's not really accurate. For a long time, they thought this is how it was, but that's not the case at all. In reality, the way the area that electrons are found around the nucleus is far more complicated than just a than like a little flat orbital ring, like it's orbiting a solar system deal. It's much more complicated than that. In reality, they orbit they just exist around the nucleus in these three-dimensional probability clouds called orbitals, and it's kind of weird. But that's we're gonna the notes have a lot to do with this, and they explain a lot. I'm just so you should be checking out those. This is just kind of meant to be like a quick little supplement to talk about some of that stuff. So, what I'm going to try to do is this. Just really quickly, I just kind of want to outline how we can think of the arrangement of electrons around the nucleus. Now, before we get into that, though, let's just take a look. So, the way it works, electrons are, like we said, they're not in those nice little rings. Instead, they're in these things called atomic orbitals, which is it's like a three-dimensional region around the nucleus where we think electrons are going to be. Now, that's not such a simple thing. It's not just like, it's just saying that we think in general that this is where the electron will probably be, any given electron, based on the amount of energy it possesses. Now, to show you what some of these look like there are different types of orbitals. There's an s orbital, which is basically like a sphere. That's the lowest energy one. All right, then you have a p orbital, which is kind of like a dumbbell-shaped thing. All right, where this is like, it's kind of dumbbell-shaped. There's 3 of those. It's a little bit higher in energy. Then there's the d sublevel, which you get these ridiculous shapes. It's 5 of them. And there's even more ridiculous shapes. There's the f sublevel, where it's just like crazy. So there's these 3-dimensional shapes, and it's confusing. It is not something simple. Now, thankfully, you don't have to memorize any of the shapes or anything like that. Well, you need to know that S is a sphere and P is a dumbbell-shaped thing, or like a bowling ball stuck together, but we'll talk about that more in a minute. The other ones, though, you don't need to know at all. But the basic idea is this. The goal right now is to predict where electrons are likely to be found. All right, likely to be found. So I want you to think of it as like if we were going to write a letter to an electron, like how would we address it? So the way it's going to work, the overreaching thing, the overall organizational structure for an electron is its energy level. All right, so it's the energy level. Now, energy levels, as you see in the activity we're going to do, and you look at the notes, energy levels are noted pretty simply. We have energy levels 1 through. I'll show you. We have energy levels 1 through 7, and that corresponds to, look at this periodic table, that didn't go away. This corresponds to periods 1 through 7 on the periodic table, just so you know, so keep that in mind. The periodic table is going to come back in a big way now. So we have 7 possible energy levels that electrons can be found in. That's the biggest organizational thing. All right, the next thing down is a sublevel. All right, there are 4 possible sublevels within each energy level. Theoretically, not every energy level has every sublevel, but in theory, there are 4 possible sublevels. All right, these sublevels are named S, P, D, and F, and they have these goofy shapes. All right. Now, are you going to need to remember those? Yes, you actually are going to have to remember S, P, D, and F. All right. Now the sublevels are composed of different orbitals. All right, so they are made up of orbitals. All right. Now, what that means is like if you take a look at the D sublevel. So the D sublevel, these goofy shapes right here. How many different goofy shapes are there? Well, there's 1, 2, 3, 4, 5 potential goofy shapes, or in what the really term is, they're orbitals. So each one of these different three-dimensional probability clouds is an orbital. All right, and there are 5 of them. Just as an example here, take a look at the P sublevel. There are 1, 2, 3 of them. There's only 3 of them. Look at S. There's just 1. F has 7. So the point is that orbitals are sort of they're the actual cloud in which where we think an electron can be found. And I'm going to explain that a little bit more. I know it's a little confusing still. So we have our orbitals, and the orbitals are inside the orbitals. We actually have our electrons. So that's sort of the deal. So if you were to think about this, think about it in terms of like arranging, like writing a letter actually. So like to yourself or something. Like to address something to you, they're like you start out very broad and generic, like what country do you live in? Like, oh, the United States. What state? Michigan. What city? Like Plymouth or Canton or whatever. All the other cities around here, or Dearborn Heights, or West Bloomfield or whatever. Lots of cities. So you say which city, or you write the zip code down. All right. And then you keep going, and then you can get really specific. You can be like, oh, you got to write your street address. Cool. Okay. But then like you can get even more specific. Like, oh, it's a street. Well, like, which house is it on the street? Oh, and this goes beyond the letters thing a little bit. Then like then you want to be even more specific, a little creepy. You could be like, well, what floor is the person on in the house? Are they on in the basement, the ground floor, the second floor? Maybe you have a third floor in your house. Aren't you fancy? And then what room are they in? Are you in like the first bedroom, the second bedroom, the third bedroom? And you can even be more specific. Maybe you have like a brother or sister that you share a room with, and you have bunk beds, and it's like which bed are you potentially even in? Like we want to be as specific as we can when identifying where electrons probably are, and this is kind of that level that there's more than this, but this is the basics. All right. So we start at energy level. Energy levels are made of sublevels. Sublevels are composed of a number of orbitals. And inside those orbitals, we have electrons. Now, the idea of the orbital, it's a probability cloud. And what that means, it is a region of three-dimensional space. It means it's just like a region, like an area, where we are likely to find an electron. It's the region where it's sort of the region where we are likely, about 90% of the time, to find an electron. All right. So it's this three-dimensional area. So it's a three-dimensional area where you are more than likely to find an electron, a specific electron depending on its energy. Now, electrons aren't always there. These are called probability clouds. And that means that about 90% of the time, we think an electron will be in this general area that we predict. It's sort of like saying for you guys, like, so if let's say we were in school and this was first hour and everything was normal in the world and it was first hour in class right now and it was about we'll say it was like 8:15. All right. Or no, I'm thinking of old school times. Let's say it was 7:42. At 7:42 during first hour, all of you, like if I was to predict where most of you would be, it's probably a safe prediction. About 95% of you are probably like in your seats, at your assigned seats in your desks, first hour in normal class, right? At 9 or at a 7:42 or whatever on like a Tuesday or something, right? You'd probably be in your exact spots, and that'd be cool. Maybe one of you's in the bathroom, maybe one of you's absent, like whatever, like not everybody, but like most of you. The probability is high that you're there. We do the same thing with an electron. So let's say we have an s orbital is basically a sphere. All right, it's just like a circle. So let's say we have this s orbital. So imagine the sphere. There would be potentially 2 electrons there would be 2 electrons potentially inside that s orbital. And with about 90% certainty, we can say they're probably there 90% of the time. But they move around, they got a lot of energy, they move around. But that's how the orbital theory works, is that we can predict with about 90% probability where electrons are. All right, so the s orbital is a sphere. The p orbital, it's this sort of this dumbbell-shaped thing where you have these 2 lobes, sort of these areas, and then that's sort of the deal. Now, there's one s orbital. In theory, there's one s orbital max. In theory, there are 3 potential p orbitals. All right. And they kind of look like this. They're all the same shape, but you need to think of them in terms of a 3-dimensional plane, all right, where you've got the nucleus is right in the middle. All right, so the s orbital is pretty easy to just visualize. All the nucleus is right there. It's in the middle. Simple. Okay. But then the p orbital, imagine that you have these 3 things, and they're kind of along the different axes that exist. So you'd have a p orbital that might be on the x, on the y, and then on the z-axis. All right? And that's sort of their general orientation. Again, with the nucleus in the middle, you'd have the s orbital in here too. It gets really crazy. Then you would have these d orbitals, all right, which are even more energetic, and there's like a bunch of them, and they're all out here. Then you would have the f orbitals, which are like even more out there, and it's too much. And that's just in one potential energy level. Then they overlap, and then you'd have like another energy level with potentially all of those again in it. It gets really crazy. Now, thankfully, you don't have to know that level of stuff. That's beyond what you've got to really take in right now. The big ideas that you need to understand are that orbitals, they are 3-dimensional probability clouds. All right. So they are 3-dimensional probability clouds where we are likely to find an electron. All right. Sorry, sneezing. It's cold. It's freezing in here. But whatever. I should put like a sweater on or something. But you got your orbitals are 3-dimensional probability clouds. The general organization that this goes, it goes energy level, sublevel, down to orbitals, and electrons. Now, and you're going to do this whole electrons address activity, which is going to talk about all of this. It's going to give you the specifics. It's going to give you specifics. There's another video I have on there about it's like shows you a 3D model of what the orbitals all look like stuck together around a nucleus, kind of like this, but done better because it's modeled out. And then one other thing to remember: orbitals. How many electrons can an orbital hold? All orbitals, regardless of their shape, can hold 2 electrons. That's it. Doesn't matter. So like an s orbital, like the single s sublevel that exists, it has 1 sphere. How many electrons can it hold? 2 electrons. The p sublevel, it has 3 orbitals. Each of these separate orbitals, how many electrons can it hold? Well, this one can hold 2 electrons. This one can hold 2 electrons, and this one can hold 2 electrons. All right, and the p is really easy to tell because you have it's like, oh, well, 1 electron would probably be over here, 1 would probably be over here, and that sort of makes sense. All right, now with this idea of them each holding 2, how many total electrons do you think a p sublevel can hold? Well, 2 plus 2 plus 2, 6 electrons. The s sublevel can only hold 2 electrons, and then there's more. So if you want to keep thinking about it, then you can think about like D. There's 5 of them: 1, 2, 3, 4, 5. Each of these goofy orbitals, they still can only hold 2 electrons max. So like this thing, 2 electrons. This thing, 2 electrons. So D can hold 2 times 5, 10 electrons. F is 7 times 2, 14. Again, I'm going to show you that in a separate video though, where we go over that practice sheet. But this is the big idea. This is the general structure. This is how it's organized, how you'd identify where an electron is. Energy level, sublevel, orbitals. Orbitals hold 2 electrons. The sublevels have these letter names, S, P, D, and F. And that's the really basic idea. Now I'm going to record another one where I show you how to do the electrons address stuff. And then we'll talk about orbital diagrams, where we're eventually going to be writing out, specifically detailing how all of the electrons in an atom are arranged by drawing arrows and diagrams. It seems confusing for the first like 20 minutes, and then it's really easy actually. So, but that won't be until after Thanksgiving. So, all right.